Hello, my name is Yuri. Thanks for pronouncing my surname right. Tsitrinbaum, it's not an easy one. Our mission is to reduce 1 gigaton of greenhouse gases from the atmosphere in an economically and operationally effective way. In our analysis, the key constraint in scaling atmospheric greenhouse gases removal lies in the complexity of processing large volumes of air in an economical fashion. To remove just 1 ton of CO2 from the atmosphere, you need to process close to 1.2 million cubic meters of air. Given the fact that revenue from 1 ton removed is just $100, that's a significant operational constraint. Therefore, our approach is not to build new infrastructure for this purpose, but rather to utilize existing infrastructure, which already sees large volumes of atmospheric air. Imagine a 7 megawatt wind turbine, 200 meters tall, 160 meters wingspan. As it generates electricity, it spins through the atmosphere. Effectively, each and every one of those turbines would process close to 150 billion cubic meters of air annually. By integrating our technology on the blades of wind turbine, we turn it into a dual-purpose asset. It continues generating clean energy while also removing greenhouse gases from the atmosphere. Effectively, we transform each wind farm into mega direct air capture facility. At the core of our technology is cutting-edge chemistry, a process called photocatalysis. Essentially, it enables the reduction of a greenhouse gas into an environmentally benign product. To transform a wind turbine into a dual-purpose asset, we need to do 2 things. 1, coat its blades with proprietary coating, and second, integrating a source of energy, light. Once we upgrade the turbine, each 7 megawatt turbine can remove up to 10,000 tons of CO2 equivalent per year. That's more than double of the largest operational direct air capture facility today. Because we leverage capex someone else already paid for, we're able to get very favorable unit economics. A ton removed would cost us close to $50 per ton. Now, with 100,000 turbines, we can reduce 1 gigaton. I admit this is quite an operational challenge, but even with just 1,000 turbines, we can reach removal of 10 million tons removed per year and generate close to $1 billion in revenue. Now, given the fact that there is 350,000 turbines already deployed, there is no lack of infrastructure to integrate with. And the key enabler of scale is the value proposition to the wind market. A turbine today would generate between $1.2 and $1.5 million in electricity revenue. We believe we can increase that revenue potential by 80%. We've built our team, completed our business validation, raised our pre-seed, and have established our research infrastructure. We're working towards a chemistry proof of concept within the next 12 months. Our team brings together professionals from the business disciplines, science, and carbon markets. And my co-founder is Nir Marom, who is a serial entrepreneur and chairman for Bomvento. Thank you. Join us in... Thank you.
Thanks, Yuri. Wasn't clear if there is any byproduct or a product that you need to do something after the conversion of the nitrates?
Sure. So essentially what the conversion, the output of the conversion is environmentally benign products. So N2O would be reduced into nitrogen and oxygen, which are released into the atmosphere, and CH4 methane would be reduced into water and CO2. So essentially significantly reducing the CO2 equivalent footprint of the gas removed.
But I mean, there's nothing that needs to be collected or...
No,
okay.
No, that's an advantage because it reduces the operational complexity, and it's a disadvantage because it is an MRV challenge.
Hi, Maria from Tehran. I have a question about the importance of dust removal, and obviously it works on surface, so how can you keep clean the such huge systems?
So it's a really good question. So essentially, the pollutants on the surface of the blade is a challenge, and essentially it should be it's addressed naturally, just with the centrifugal force of the movement of the turbine. But it's also we need to be addressed within the designing of the coating. So the coating should be such that essentially doesn't allow pollutants to stay on the surface of the blade.
Thank you.
Thank you.
I have a final question.
Yes.
Dave from E44 Ventures. Can you apply it on old blades or just on new blades? And team diversity need to be uplifted.
We will work on team diversity. I agree. Regarding surfaces, so essentially our like turbines is just one surface. Every surface would be actually relevant for such a transformation. Our focus is to build a process that can be integrated both for new turbines and refurbishing or upscaling existing turbines already deployed. Thank you.
Thank you so much. Thank you so much.